Let's explore the science behind fat loss, how fat is stored, how fat is burned, and why the do we have fat in the first place? The thing is, food was a luxury throughout the entirety of human evolution. It was just 100 years ago that the German scientist Fritz Haber developed synthetic fertilizers that allow for mass-scale agriculture. Before that, we lived in scarcity, in an environment where a calorie is precious and cannot be wasted. But Mother Nature is really smart and equipped us with the ability to store the energy from the food that we eat, the energy that fuels our body. So whenever we were able to find food and our energy requirements were met, storing the extra energy as fat was key to the survival of the organism. And how we store fat mechanistically is pretty simple. Whenever you have more energy coming in your body than you are spending with all the biological functions of your body and the movement and the stuff that you do during the day, you are in a caloric surplus. A caloric surplus only means that you are ingesting more energy than your body requires right now. And that's an important distinction. Sometimes people say it's the amount of energy that you need to survive, but it's not what you need to survive. The metabolism is very plastic. This means it changes according to stimulus very easily and very rapidly. It can be used to optimize other biological functions that aren't necessarily optimal for survival. Muscle is the greatest example of that. Carrying a lot of muscle, even for a guy like me, natural and that is tiny. I weigh 170 pounds, but right now my body requires way more energy than it required before I built all that muscle, which is not that much, but it's sufficient to raise my metabolic rate to a metabolic rate that isn't exactly optimal for survival. Is optimal for the state that my body is in right now. And in the context of using the extra resources that put you in a caloric surplus to build fat, it happens through a process called adipogenesis. Adipogenesis is when your body builds a fat cell, a brand new fat cell. That brand new fat cell, it's empty, but it has the ability to, over time, if you stay at a caloric surplus, to accumulate lipids and triglycerides within it, enlarging the fat cell and get us chubby as fuck. No, it makes that energy that is stored within the fat cell available for when you are not in a caloric surplus. Quite the contrary, when you are in a caloric deficit. Before we start talking about how the body burns fat mechanistically, we need to touch on the metabolism. You need to understand what the metabolism is. The metabolism is every single process within your body that uses the food and drinks that you eat to produce energy or materials inside the body. Everything your body is doing requires energy, and that energy is provided to you by food. Managing that energy, deciding where the resources are going to be used, is a task of your metabolism, not just as it relates to fat, but everything inside your body. So when you think, okay, now I'm going to implement a caloric deficit, I'm going to reduce my calories so I can lose some fat. You need to understand that the entire system is being affected by your decision. Not just fat, everything is being affected. So when you see some motherfucker online saying, my metabolism was 2000 and now is 1800, what caused that drop? Is that drop healthy? Is that what you want? People don't think about it in these terms. Usually they only think, okay, law of thermodynamics, caloric surplus, caloric deficit, and that's all that matters, calories in, calories out. But they don't think of the implications of reducing your metabolism intentively, putting yourself under a 1000 caloric deficit, and then just watching your metabolism go down. How many gene expressions and other functions of your body are being turned off and completely disrupted by your attempts at doing this just by strictly reducing your caloric intake? Now, don't hear what I'm not saying. Studies show that caloric restriction is actually very healthy and can expand your lifespan significantly. But what about performance? What about vitality? Lifespan and vitality, they work in two different directions. A good example of this is testosterone. There are several experts that say that testosterone will raise your vitality, will raise your health span, will make you fully function inside society in the deeper stages of your development. But it can also impact negatively your total lifespan. But that's a topic for another day. Let's keep talking about the caloric deficit. Specifically, how the caloric deficit makes you lose fat. You probably already learned that you need to burn 3,500 calories to burn 1 pound of fat. But since my mojo is not to turn fitness into a math problem, I want to talk about how fat loss happens, how the fat is eliminated from your body. It happens in a process called lipolysis. Lipolysis has 2 steps. The first step is fat mobilization. Remember when we were talking about the caloric surplus? The caloric surplus created the fat cell. The fat cell then got infused with lipids and triglycerides that was running around in the bloodstream. Fat mobilization is when these lipids and triglycerides triglycerides that are stuffed in the fat cell are released back in the bloodstream to be used in other parts of the body because there's a caloric need that isn't being met by the caloric intake, the caloric deficit. And when the fat cell is completely depleted of all that gunk that was stuffed in it, it generates the opportunity for the second part of lipolysis, fat oxidation, the actual elimination of the fat cell. And here's where things start to get really tricky, because if the fat isn't used after it's mobilized, or if there's a constant infusion of lipids and triglycerides in the bloodstream that will stuff the fat cell full of gunk back again, fat oxidation will never be possible. And it's even worse. If you don't spend the fat that was mobilized, it goes right back to where it was.